In this video, we're going to look at the chain, product, and quotient rules if we're dealing with things from a table. And so you can see here we have a table of values. We have a table right here. Table of values. We have f of x for 0 to 6, g of x for 0 to 6, f prime of x for 0 to 6, and g prime of x for 0 to 6. And we're going to use those to make some calculations. Alright, so we've given some definitions here for h of x, k of x, and j of x. It says h of x is f of g of x, so it's the composite function. There's a function inside a function. That's a classic chain rule. K of x is f times g of x, product rule, and j of x is f of x divided by, it should actually say g of x, which is the quotient rule. So in order to, they want us to find h prime of 2 here. H prime of 2. And these three are all going to be quite, once we do one of them, we can do all of them. So in other words, we need to know h prime of x. Well, all we know is that h of x is f of g of x. So if we take and use the chain rule on that to find h prime, it'd be the derivative of the outside, which would be f prime times g of x, times the derivative of the inside, which is g prime of x. So I've just taken the derivative using the chain rule. Now, I take the, and now I do h prime of 2 is going to be f prime of g of 2 times g prime of 2. Well, g prime of 2 is 5. G of 2 is also 5, so we're finding f prime of 5. F prime of 5 is 4. So h prime of 2 is 4 times 5, which is 20. And that's our first one. The other two are done in the same manner. So h prime of 3 would just be f prime of g of 3 times g prime of 3, which would simply be f prime and g of 3 is 3, and g prime of 3 is 4. F prime of 3 is 0. So this one, all that work, h prime of 3 is 0. H prime of 3 is 0. H prime of 5 can be done in a similar fashion. And I'll leave that to you. Now k of x is f times g of x. So I've got to use the product rule. So that would be, to find k prime of x, it would be the first times the derivative of the second, so f times g prime, plus the second times the derivative of the first, which would be f prime. So if I'm going to plug and do k prime of 4, it would be f of 4 times g prime of 4 plus g of 4 times f prime of 4. Well, let's look back up here and find out what those are. F of 4 is negative 9 times g prime of 4 is 0 plus g of 4 is 3 and f prime of 4 is 4. So if we do math on that, that of course is 0. 3 times 4 is 12, and so that is k prime of 4. J prime of 5, well, I have to know j of x is f of x divided by g of x. So if we want j prime of x, we'd have to use the quotient rule, which would be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. It's just the definition of the quotient rule. So here, if I'm going to find j prime of 5, I want g of 5 times f prime of 5 minus f of 5 times g prime of 5 all over g of 5 squared. If I plug those in, so g of 5 is 2 and f prime of 5 is 4. So this is 2 times 4 minus f of 5 is 11 and g prime of 5 is negative 3. So 11 times negative 3, and g of 5, we already said it was 2, so 2 squared, which of course is 4. So this one would simplify, it'd be 2 times 4 plus 33, so 8 plus 33, which is 41 over 4. So j prime of 5 is 41 over 4. Now k prime of 6 and j prime of 3 can all be done in exactly the same way. And let's look at the last question here. Which function has a maximum on the interval 0 to 6? Where does the maximum occur? Well, a function has a maximum when it changes from increasing to decreasing. Its derivative changes from positive to negative, and often, many times, the derivative is 0. So let's look at our derivatives. There are 2 times. F prime has a derivative at 3. Right here we can see f prime has a 0 when x is 3. However, this is negative and this is positive. So in other words, the f is changing from decreasing to increasing. F has a minimum at 3. Okay. So if we can also see g prime here has a 0 at 4. And this is positive. So positive to negative, which means g changes from increasing to decreasing, making it has a maximum at 4. So g has a maximum at x equals 4 because g prime changes from positive to negative at x equals 4. Good.